Hello everyone, today we'll be taking a look at how you can remake Pong inside of Godot, like you can see over here. We have a built-in AI system, we obviously have collisions, and we will be taking a look at inputs and how we can actually program this to handle everything properly with the best practices in mind. So without further ado, let's get straight into the tutorial. Alright, so we start off by creating our nodes. So we're inside an empty project and we simply want to make a new 2D node. We'll call this main and let's save that to its own scene. Then we want to make a player node, which will basically be a static body 2D. We'll name this player and let's actually go ahead and add a color rect into this, which will be the rectangle or the paddle. Then also a collision shape, and we'll duplicate this to be the same for our computer. So in the color rect, we'll go ahead and set the size to be 10 by 120. We'll do the same for the computer. Then we want to align the color rect to the center left. And then we also want to move this color rect or even the entire player node over to the center of our screen. So in this case, that would be 120, or let's actually just keep this 20, and then this should be 240 because we have our project size set to 640 by 480. Then for the computer, we also want to move this to the right. We also want to make sure we have this set to that. And then we move this over to the end here, which would be 600. And then also 240, so it's centered. That's close enough, I'll just keep it like that. Then we want to add a collision shape onto the player and the computer. So we basically make this match the actual size of our paddle here. There we go. New rectangle shape 2D. And there we are. Then let's make our ball node. Now the ball node will be a character body 2D. We'll rename this to ball. We'll also add a color rect and a collision shape. Whoops. Now let's resize this to be 10 by 10. And we'll center this. And then also we want to make sure we reset the position to be at the center of our screen. So 320, 240. Then for collision shape, we'll just make this a rectangle as well, just to keep it easy. And let's resize this to also match our ball. Then for later on, we want to add a timer, which we'll rename to ball timer. Now this will be responsible for actually starting the game, so that we first start with a 1 second delay, and then the ball will go to a random direction and we can play the game. Also make sure we have one shot and auto start enabled here, otherwise the ball won't be actually moving. So then let's get started with some scripts. We'll start with the player script, which will be responsible for detecting movement up and down, and we'll also go ahead and make sure that it does not go out of bounds. So let's start by creating some variables here. We'll have one that is the window height, and one that will be the height of the paddle. Then we also want to get the color rect in here, so we select it, we drag it, and we hold control while we get rid of our mouse 1, or while we release mouse 1. Then in our ready function, we want to go ahead and set the window height and paddle height to its initial value. We do that by getting the Y value right here of the viewport. And for the paddle height, we want to get the size of the color rect we have initialized, and we get the y value. Then in our process function, we want to go ahead and add two if statements to check whether we are going up or down. So we do if input.isActionPressed, UI up. We will go ahead and set the y position to be deducting the paddle speed. So we'll actually do this. And then for the down key, we want to make sure we go ahead and add on to the y position. So position.y plus equals paddle speed times delta. Actually, we want to make the paddle speed a global variable. So let's actually make our main script here, and we will only define a const that is the paddle speed, which will be an int of 400. So this way we can later on reference it in computer as well as player without needing to have two variables right here. Instead, we just have one in our player script. So now to reference the const that was in the main script, we want to type getParent, and then we can reference the const like so. And then we want to make sure we don't go out of bounds. So to do that, we can use the clamp function, which will take our y position, our pedal height divided by 2, and then the window height minus the pedal height divided by 2 as well. So this will make sure that we can't actually move outside of our box here. As we can see, when we move the player, we don't go outside of our screen. Very nice. So then let's get started with creating our computer script. So we go to the computer node, we create a new script, and in here we will basically program a small AI that will basically go towards the ball at its speed and hit it back when he's obviously at the location he wants to be. So let's define a couple of variables. Those are pretty much the same as we had before. Then we want a ball position, which will be the position of the ball, so that the AI knows and can calculate the distance to the ball, which will be its own variable. And then the ball distance, which will be the distance that it's away from the paddle. Or let's actually just keep this distance, it's not to the paddle. And then we also want to reference our color rect for later on. So then inside our ready function, we want to initialize the window height and the pedal height again. So we can simply go back to the player and we can just copy this, because that's the same as we have done in the player script. Then inside of our process script, we can go ahead and get a reference to our ball position. So to do this, we want to actually make sure we also reference our ball here. And then we can simply do ball position equals ball.position. Then we want to calculate the distance, and we do this by getting our current position minus the ball position.y. So that way we know the distance. And then we want to make sure we set the distance to the ball, and we calculate that. Now we do this by getting the ball speed again, so the paddle speed I mean. We multiply that by the delta, and then we multiply that by the distance divided by its absolute value of the distance. So this way we get a more normalized way of checking the distance towards the ball. If we weren't adding this here, the distance divided by the absolute value, then it would get a little bit choppy, so that way we have a more solid motion of going towards the ball. Then we also want to make sure we actually do an if statement here, so we make sure we get that smooth transition I talked about. We make sure we indent this by 1. And then we have an else, and we will simply just set the distance to the ball to the distance if it's not greater than the speed times the delta. Then we want to make sure we set the position of our pedal to be deducting the distance to the ball so that we know at what speed we want to go and we know what y value we need to use, and we want to set the AI pedal at when we are going to be hitting the ball. So then we can copy this clamp function right here from the player script back onto our computer script, because this is the same issue we would have if we actually didn't add that. The AI would also simply not move all the way to the top, or it would even go out of bounds sometimes. So that way we use the clamp function to make sure we stay within the window that we have set up. So let's get started with coding our ball script. So we can go ahead and create a new script. We call it ball.gd. Now this will be our biggest script because we'll have to handle collisions and also check for boundaries, and we can also even implement a way to know that we have scored a point. So let's start by defining our variables. So we'll actually make some consts here now as well. That'll be the speed at which the ball starts, and we'll also add a acceleration that will basically add 30 speed onto our start speed every time the ball will get hit. And then we have the window size, which speaks for itself. And we also want the direction the ball is going in, so we can bounce it off of the paddleboard or off of the boundaries at the top or bottom. Then in here, we also want to reference our player, our computer, and we also want to make sure we have a reference to the collision shape of the ball in here. I'll name it collision shape. You can name it whatever you want. Then we make our ready function, which will only set the window size to be the correct size. So we get viewport rect.size instead of only the y, because we want the entire size of the window. Then we make a function in here, which is the initialize ball, which will basically set the position, and it'll also randomize the location at which it's going, so that it's always random when we start a new game or when the ball is going behind the paddleboard, so that it restarts and plays the game again. So we want to set the position to be random, as I said. So we use the window size x position divided by 2, so it will always start in the middle. But then we want to randomize the height at which it goes. So we can do the randf range, and we want to make sure we do that in a range of 200. And yeah, the window size y position minus the 200. Then we want to also set an initial state of our ball speed. So that will be done like this. Just initialize that. And then we want to set the velocity of the ball to be the random direction times the speed. So the random ball direction is the first function we'll be making here. There we go. To return a vector 2. So we basically define a new variable that will be a vector 2. Whoops, we can actually do it easier by doing that. Then we can set the x position to be between 1 and -1. So that it goes left or it goes right. And then we want to set the y value to also be a random value between -1 and 1. So we have a bit of randomness at which rate it goes up or down. So we do this actually by not doing that. We want to do it like this. And then we want to return this value and make sure we normalize it. Ah, yeah, this is supposed to be ball speed. And then this is also like so. think. There we go. That should be it. So we have gotten rid of those errors. So let's see here. We have pretty much almost done the ball script. We have a new random location. Now we want to make sure we actually do something with the collisions. And if we actually were to add the timer onto our main script here, so we can do that by going to the ball timer, node, signals, and we want to add a timeout here. We can put this onto our main script. And then in here, what we can do is we can reference our ball. So we can go ahead and add that in here. And then we can do ball.initialize ball. And then once we run this code, after 1 second, it should actually move around. I have probably misspelled it again, like I did before. Yes, I did. So there we go. We just saw the ball moving, right? So that's only because we only set the random position for now. So now let's actually go ahead and make sure the ball just goes where it wants to. And we can do this by using the physics process function of Godot. So let's do that. We basically want to check for collisions, and we also just want to simply move when we actually can move. So let's write out that function. We store the collision inside of the collision variable. We simply want to move based on the velocity and its delta. And then if there is a collision, we want to actually handle that collision, and we want to check if it's actually with a wall or if it's with a player or a computer. So let's write out the handle collision script. So I actually like to type all of my variables and parameters, but you obviously don't have to do that if you don't want to. So let's store the collider in its own variable. And then if the collider is basically colliding with the player or the computer, we want to do something with that, right? So we actually want to update the ball speed, and we want to add the acceleration part onto that. So we always go a little bit faster once it hits the player or computer pedal. So we do ball speed plus equals acceleration, and that's that. So then we also want to have an updated velocity because we just changed the ball speed. So we do the velocity, which will also bounce actually. We bounce it first. So that way it basically, once it hits the pedal, it'll just go back the other direction, which is pretty nice, and it's actually built into Godot, so that's a very easy feature to implement. And then we actually want to set the velocity speed and basically update that to make sure we use the new value. There we go. So now we will see that it actually bounces up and down. And we also see our next problem, which is we haven't set up the boundaries. So now it just goes out of the screen when we actually engage with a wall, or even if it goes behind the player, it doesn't bounce back. Or doesn't restart the game in the case when it goes behind the pedal. So let's go ahead and handle the boundaries. So we can go back to our physics process function, and we want to reference another function, which will be handle boundaries. Now this function will be responsible for checking whether we hit the top or bottom, or we hit the left and right, and actually do something based off that. So the handle boundaries will have a couple of variables to start with. We want to make sure we get our rectangle. Then we want to make sure we get the width and height, or well, half of it. And then we want to write a couple of if statements to check whether we hit the top or the bottom of our boundary here. So first let's start with the top and bottom. So we check whether it has gone to the bottom. So when it's below 0, we obviously don't want that, and we can, well, pretty much assume that it's out of bounds, right? So then if that happens, we want to make sure we invert the velocity to basically go back up or down based on whether it's in this part of the if or the other. So that way we make sure it bounces off of the top and bottom and doesn't go through it. And then this last part is basically checking if it's in the top half of our screen. So it hits the top, and if it does, we also want to invert the velocity. So to do this, we can simply go velocity.y is basically minus velocity.y, which will mean that it'll just invert it in this case. And then we also want to set the position of our ball to be actually the clamp again. So the clamp we use again to check if it's out of bounds, or not check if it's out of bounds, it just makes sure it doesn't go out of bounds. So we use the Y position, and then the half height, the window size, the Y minus half height as well. So that way we make sure that it doesn't go out of bounds. Then we also want to check if it's going to go behind the pedal or in front. So we go in here and we check the X position minus half of its width. This way we make sure if it's less or, yeah, if it's less than 0, we are behind the player on the left here. And then this one is for the player on the right. So then what we want to do is we want to spawn a new ball. What you could also do in here is add a score. So you have a label where you keep track of the score. And then you would also use that in here to determine whether the player scored or the computer scored. And I still can't type it. There we go. So now, when we run this code, we'll see that the game starts after 1 second. Our AI is working, and it also bounces off of the top of their screen here. So let's see if I can score against this AI. There we go. We just saw that it went behind the AI's pedal, and the new ball spawned right away, and it had another position that it had at the beginning. So yeah, that seems to be working just fine. You could obviously expand upon this by adding a score, for example, or you could also add lives. It just depends on what you want to do. But I just wanted to show you the most fundamental parts of this, and then leave it open to expansion on your own. If you have any questions or problems, please let me know in the comments below, or you could join my Discord and ask them there, as I'm happy to help. So without further ado, that was it for this video, and I'll see you next time. Bye bye.